Hi, this is the University of St. LaSalle College of Arts and Sciences Mathematics Department. Next up in our series of Algebra 101, we have the solution video actually of the operations of functions. If you can remember in our last operation of functions video, that's in the part 2, we have given you some exercises to do there. So the exercises that I'm talking about are these 1 to 6. I'm not going to read it again. So I believe you have some answers there. And yes, in this video, we're going to answer all of them. Okay, starting with number 1. Okay, number 1 is f over g of x. So f over g of x, that's quotient functions. That's a division of functions. So we're going to put it as in this form. So f of x over g of x. So f of x is 2x, g of x is x plus 1. So what we'll do is substituting the values of f of x as 2x, g of x as x plus 1. That will be this. And then we'll try to see if we can simplify this form, this fraction. Okay, so as we can see, we cannot. That will be our final answer then. Okay, just a common mistake. Most of the time, we cancel the x's here. Okay, so that's a very wrong move to do actually. So we cannot cancel something which is not factorized. So x plus 1 here, the x here is part of a binomial, which is x plus 1. So we cannot just simply choose to cancel out x here from the denominator by the x and the numerator. So it should be factorized. Okay, so we cannot do canceling here. That will be our final answer then. Okay, so for number 2. Number 2 gives us f plus g of x. Okay, so again, that's addition of functions. That's going to be f of x plus g of x separately. So f of x is 2x again, g of x is x plus 1. Substitute them with a plus sign. Again, it's much better in practice to put them first in parentheses. Okay, and then we'll do our substitution, or rather our simplification. Okay, so we will like to combine like terms here. Again, like terms are terms which have the same variables with the same degree. Okay, so simply put, we can combine these 2x with the x here on the other side, since x here has a degree of 1. This also has a degree of 1, so we can combine the coefficients. It has a hidden 1 here, and 2, so 2 plus 1 is going to give us 3x, and then copy the constant 1 here. And that will be our answer for number 2. Okay, hopefully you got it right. Number 3, we have f times g of x. F times g of x, so simply put as multiplication. So f of x times g of x, there's the values there. That will become 2x times x plus 1. Okay, so now we're multiplying a monomial by a binomial. So we're just going to distribute this by distribution property. 2x times x, that's going to become 2x squared by our log product. We're multiplying variables, so we need to add the exponents. 1 plus 1 is 2. That's why 2x squared. And then distribute this 2x to the 1 here, that's 2x. So therefore, we have 2x squared plus 2x, and that's our final answer for number 3. Okay, for number 3. Let's do number 4 now. Number 4, so we have h minus g of x. Okay, so we have h now as x squared minus 1, g as x plus 1. So we're going to put a minus sign in between them. That will be like h of x minus g of x, substitute the values, and then what we'll have is this one. Again, in practice, better to put them in parentheses, okay? So we have x squared minus 1, that's our x, or rather h of x, minus our g of x plus 1, okay, in parentheses. Why do we need to put them in parentheses? This is where the parentheses gets useful, okay? You see this minus sign here? Okay, without the parentheses, we might be inclined to put the minus sign only on the x, but actually it should be distributed. This minus sign here should be distributed to the x and to the minus 1, not only on the x but to this whole binomial. So if we're going to do that, this x, since it's positive, it's going to become minus, and this 1, since it's minus 1, it's going to become plus. So therefore, our next line would look like this. Okay, so copy the h of x terms. So x squared minus 1 minus x plus 1. Okay, combine like terms. So we cannot combine anything with x squared. Most common mistake also, they tend to combine this one and this one, which is of course not correct because they don't have the same degree. They don't have the same exponent, so we cannot combine them. Simply write them down. Okay, in a um, in a decreasing degree form. So that's the in practice that's the best picture for a polynomial. One with the highest degree should be put first. And then we combine the constant terms. -1 plus 1 is going to become 0, of course. 1 minus 1 is 0. That's going to be our final answer then. And we cannot simplify more. That's our answer for number 4. Okay, number 5 now. So number 5 is g times h of x. So again, g of x written here, that's x plus 1 substituted here. H of x is x squared minus 1 substituted here. So what we'll have is this one. Okay, so we're now multiplying two terms here. To be exact, we're multiplying binomials, a binomial to a binomial. So if we're having this kind of form here, we're going to use a method, a fairly popular method that's called the FOIL method. FOIL, that's FOIL. First, outer, inner, and then last terms. Okay, so for the first terms, we're going to multiply x times x squared. So x times x squared with the law of product and exponents. It has a 1 here, it has a 2 here. So we're going to add the exponents. That's going to become x cubed. Okay, we're done with the f. Let's go with the O, outer. X times minus 1. Well, x times minus 1 is going to give us minus x. That's our O. Let's go to the I, inner. -1 times x squared. That's going to become negative x squared or minus x squared. Okay, and then we're done with the I here, and then with the L last. -1 times -1. That's going to become a double negative. That's a positive 1. And that is our term here after the FOIL. Usually during the FOIL method, after the FOIL method rather, we will combine like terms. But clearly in this type of FOIL, there's no like terms. Since all the x's here have different degrees, we cannot combine them because that's our rule number 2 in our like terms system. And then we have a +1 as a constant. So there's no like terms. What is left for us to do is to put them properly in order. Okay, so we're going to put first x cubed, okay, minus x squared minus x plus 1. Okay, because that's the in practice that should be the correct one in writing polynomials. So the one with the highest degree should be put first in a decreasing order until a constant term. So that will be our answer for number 5. Okay, for number 6, this is our last item actually, h over g of x. So we're going to put it as h of x and over g of x. So h of x is x squared minus 1, g of x is x plus 1. Okay, that's it. Next question that we will be answering, can we simplify this? Okay, so the denominator cannot be simplified. That's x plus 1. That's the simplest form already. But in our numerator, yeah, we can see that this is x squared minus 1. Who can recall any factorization formulas that we could use with this one? Right, that's difference of two squares. This is a square, that's x squared. This is also a square. Okay, that's 1. 1 squared is 1, so still it's a square. It's a perfect square. Okay, so and there's a minus sign between them. So that's the difference of two squares. So if we're going to use the formula for the difference of two squares, we're going to end up with the next line like this. Okay, so this will be our difference of two squares. So we're going to get a square root of x squared, that's x, square root of 1 is 1, and then put two binomials together, 1 with the plus sign, 1 with the minus sign, and then voila, this is our answer for the difference of two squares for this binomial. Okay, so clearly now we can cancel up. This is where you can cancel, okay, a legit cancelization, as you can see, because these are factored. Okay, this is in a factored form. So we can cancel this factored form, x plus 1, to the denominator, x plus 1. Okay, you see? So therefore, this can be cancelled out in a legit way. Okay, not a mistake, but it's in a legit way. So if we're going to cancel x plus 1 in the numerator, we'll be left with x minus 1. If we're going to cancel x plus 1 in the denominator, we'll be left with 1. Okay, and then we could just clean this up by putting it here. Everything has a 1 as their denominator, right? So we could just hide this one here. So x minus 1 is our answer then. So that will be our answer for our number 6. Okay, so that ends our video here. Hopefully you get 5 marks, 4 marks at least. Okay, in this operations of functions. If you have 4 marks or or above, you can move on to the next lesson actually. But if you have more, less than 4 marks, right? For that reason, I think you could go back and see these videos again and again for you to have mastery. Okay, it takes time. It takes time to master this. Okay, so just be patient with yourself. Okay, and practice more. Practice more. That's the secret in mathematics. Practice. Okay, so that's it. Hopefully you get this. You get this lesson now. Don't forget to like and comment in our YouTube in this video in our YouTube video here, and then don't forget to subscribe. The subscribe button is somewhere here down here. I cannot move the mouse beyond the video, of course. Also follow our Facebook page, is written here, facebook.com/USLS Math, and yeah, see you soon. I'll be making a lot of videos more. We'll be making a lot of videos more videos. Okay, thank you very much.